Hi. What is this? Let me click this thing. What's gonna oh my god. This is terrible. How do I go back? 1 second. How do I'm hmm. Wait, how did I do this? Ah, I see. Okay. Okay.
Oh, can you enable screen share as well?
Screen share, yeah, for sure. Multiple participants can share. I need to, okay. Okay, you should be able to now. Hi.
Oh, I don't want the whole desktop. It will be impossible to see. There we go. All right, let's see how well this is visible. Is there a way for me to see what's on what you guys are seeing?
I see it very well, yeah.
I see the website.
Is it, you know what I can do is force it into mobile mode.
It's neat.
Yeah, I was playing around with it yesterday. I was like, how do I make this super easy to see?
Should I send a message again to the entire channel? Yes.
Absolutely. Blast them.
We're gonna do it. We're live now, and live is
We're live now. Do it to the 447 group and the 410 group as well.
Okay, I'm gonna get kicked out of the program. We can just keep it to the the audacity.
The audacity of sending it out to everybody.
Yeah.
Gotta be bold sometimes.
Yeah, for sure. How's everyone doing? How's the first homework going for people that are actually taking this class? I don't think everyone is.
I put it on pause because I was just like getting stuck. So I was just like, let me go work on some other homework in the meantime. But I finally I had to like shortcut. It was some kind of infinite loop on part one, the unigram. So I just capped it at like 28 words.
Yeah, I did the same thing. But I mean, like, I don't think like autograder like give really like insightful like debugging message. They just like say, okay, like your thing just failed one or more test case. I make some changes, like the same message. I don't know, like I'm improving or like actually degrading the performance.
Yeah,
that's a headache.
I haven't dug into it yet, but I'm wondering if the autograder is using a specific lower value for floating points or a lower a number of representation for floating point values, and maybe some of the tokens are just getting shrunk to zero. So I haven't played around with it, but I don't know. I just figured maybe that's something going on.
Yeah, I just wanted to quickly mention that there was one very weird thing that I noticed. So we were passing same corpus for testing as well as for generating sentences and counting probabilities, but still somehow if I tried to do count, then it was different. Did someone else notice that?
The count of the words for the same corpus?
Fox, I wanna quickly circumvent. I shouldn't have started this conversation. Run out of time. Do we want to give so Jamie and Samarth are new people, kind of like if you want to do a 1-minute presentation about yourself, what classes you're taking, what you're doing, if you're studying full-time or not, that kind of stuff, and then we can start with today's topic.
Sure, Reliance. Thanks for adding me to the group. So I'm Samarth, and I am taking only one course at a time in this. So right now I'm just taking NLP because of my full-time work. So I work as a senior data scientist with one of the enterprise companies here in Bay Area. So yeah, looking forward. I mean, this thing is really interesting.
That's what you.
Okay,
Thank
good. Yeah, happy to be here. This is my first semester. I'm a fall 2021 cohort member. I am currently taking CS 410, CS 498, and CS 598, and studying full-time for now, but I was most recently working in finance up until COVID hit. But yeah, to be honest, a lot of the more technical details of this paper went over my head, but I'm very interested in continuing with this group.
Great. That's very cool. Yeah. Rahul, if you want to kick it off.
Yeah, I'll take it. So just as a show of hands, how many people had a chance to get through the blog page or at least peruse it? You can use virtual hands or real hands, either way. Okay, so I think there was maybe like 2, is that right? Maybe Jamie and maybe one other. Okay, so yeah, we're not going to get through the papers per se, because I think there's quite a bit of, like we're talking about, quite a bit of technical detail. But as far as my interest was concerned, I just want to understand this concept of audio to audio versus using anything text-based. So what we'll do is we'll just start from the top and work our way down through the paper. And I don't necessarily want to go too fast. I want to make sure we understand the different parts of it. So why is my screen not scrolling now? 1 second. Okay, annotations. So, so this model is actually, they're using like 3 different kinds of innovations in a single pipeline. They're using the BERT models, the family of BERT models, as a go-between inside of the pipelines. So the BERT models are the ones that are pure text-based NLP models, and they are still using them specifically for the language model portion of it, but it's supplementary to what they're doing here. So there's an important, they're highlighting that, look, there's a limitation to these models, right? They are restricted to large text data sets, so popular languages with lots and lots of text. So my wife was just telling me, she's actually a language teacher. She was telling me that there are currently 7,000 languages in the world, and they're expecting in the next 100 years that number to drop to 3,000. So we're going to lose about 4,000 languages if we don't do something about it. Basically present day. I'm going to scroll slowly so you guys can read as we're going through this. So this is generative spoken language models. Okay, so they're strictly looking at creating new language, new spoken words from existing spoken representations, and they're using audiobooks as the primary data set to do that. All right, let's go forward. Any questions so far on those first few paragraphs?
So do you mean that they take the BERT models and then they do what's it called, the additional training on the audio data sets? Or? So
the audio data sets is the primary, the BERTs are supplementary. We'll go down when we get to the architecture, we'll see exactly what that means.
Okay.
And what is the benefit of doing this audio to audio conversion? From an application point of view? From an application,
so here we go. Like, here's a couple highlights. So one thing is that these are great questions, because you're leading right into what the blog post is talking about. So the idea that children are learning language without any concept of written is apparent, right? So there shouldn't be no reason to have a written format first to be able to speak a language or learn a language. They are using 3 components. So they have one component here, this is like the crux of everything. You have to have a representation of the audio. So they're converting the speech into their discrete units or pseudo text. Okay. Then you have a second component, which is converting those units back into speech. And then the third component is in between, which is the language model itself. That's just composed of the units. So let us scroll down to, well, first I want to talk about what's the value of doing this approach. Oh, I do want to highlight that they used a lot of different people to get to this level. Like there are a dozen people on those papers in all different fields. So this is a very sort of challenging area. Okay, so here are your benefits of this approach. So Textless NLP should make AI more inclusive and able to model a variety of languages. So we talked about 7,000 languages, 4,000 are going to disappear. So there's all these edge case languages. Hi, Sushma. Leah, has Sushma been here before? Does she want to do an intro, quick intro?
Oh, hi. Welcome. Yeah, if you want to, welcome, Sushma. If you want to give a short intro about yourself, what classes you're taking, if you're studying full time or not, what you're interested in, and I feel welcome to do that.
Just jump in whenever you get connected, Sushma. So that's one thing.
Hi. Hi. So this is my first time here, and yeah, I'm taking the text information systems as well as applied machine learning course this semester. Yeah, I'm doing this full time. Yeah, and looking forward for yeah, what's in store for me. Yeah.
Awesome, welcome. Yeah, there's a few of us taking this full time. I'm full time as well, and then and I believe Jamie as well. So okay, so first thing is obviously we're going to have access to more languages that don't have, let's say, a large written data set. Second is you get more out of verbal spoken languages than you can encapsulate in a written format. You've got the nuances and intonations, how you say something, the same thing. We've got ambiguity in text, but we also have ambiguity in spoken words. And one of the examples they give in the article here is, yeah, I had a great time. Or you can also say, yeah, I had a great time. And that can be captured in a verbal, in a spoken way that you cannot quite capture in written. Third here is that we can do audio first experiences. So there are a number of places where, sort of the creation is audio first. It is not text first. Podcasts, radio shows, social audio apps are newer, but I mean, things like news, right? News is generated audio first. So this opens up that area of study. Any questions on the sort of application spaces?
I'm just wondering, like on these applications, this last few lines there is say expressive translation. So do you mean like you just speak and it gets translated into the target language?
They're basically saying like, hey, if we're playing video games together and one person is speaking one language, you're doing real-time translation into the target language. And that would be you. Or if you're simply having created the video game in a target language for the audio, you could do real-time translation.
So it could be like those big government things, right? Where global meetings are done, like G8 summits, where people leaders from different countries come in and they say in their own language. And
I doubt anything that critical would ever be done using automation, but you don't want countries to misunderstand each other because of some computer, like who's at fault there, right? But definitely,
No,
like
I mean, that can be an assistant. You could still have your real translators, but yeah, I mean, the place where I'm little struggling to find the value add here is, and that is because, let's say, they are trained this entire thing, like you mentioned, on the audiobooks, right? Now, where are those audiobooks coming from? Are they for the regular languages, or they are like for the special languages that we were discussing, right?
they started with the regular languages, but they've got a section at the very end talks about next steps, and it seems like they're interested in going in the direction of these less than popular languages. And specifically,
Okay.
the next step they're looking at is not books, but rather impromptu spoken, like news reports and that sort of category of spoken speech.
Just like one other aspect that might come into play, like it also might help to like adjust for different dialects better, because there might be certain phrases or things that might come up, especially in like common use compared to like general discussions that would be there in like a well-written book that's like maybe set to like American or English, British English, and like those nuances might end up getting captured, which might make like these models sound like actually more natural and like better suited for like each individual locality. So that
So
might be like
they do incorporate that. That's called prosody, and they
Mhm.
incorporate that into the architecture. So they've got a separate piece for it.
Oh, perfect.
Okay, so finally, these models may help psychologists and speech language clinicians predict how infants' ability to learn and speak. So, there's some insights that can be generated. I was actually curious about this, if it could help me learn to speak more fluent Chinese, like as a native. And so, because if you train a model with how native speakers speak, you could then see where you're off in terms of your enunciation or pronunciation. Again, using an app per se. Okay, so here's where they claim they've got the first audio-only speech-to-speech translation system. This is just the paper, but there's a couple GitHubs with demo code. We'll go through that in a second as well later. So other areas they can do is sentiment analysis, like we talked about, the intonation and the spoken word, document retrieval, summarization, and more. These are standard tasks in NLP. So here's where it gets interesting. Okay, let's understand what exactly they're doing here. So can you guys see this picture very clearly? So S to U is speech to unit. Okay, so they're basically taking the raw wave file and converting it into their internal representation, which they're calling a unit. And then they've got, again, a unit to speech, which is reconverting that unit back into a speech waveform. And then the third component here is in the middle, which is the unit language model. Okay, so they're calling this process from encoding to decoding the resynthesis. Okay, and then if you're passing it through the model, that's speech generation. Okay, so just understand that first so it's in mind. And these units, they're declaring those as pseudo text units. So they tried a few different encoders, CPC, Wave to Vec, and Hubert. Hubert seems to be coming up quite a bit, so we may want to dip into that paper a little bit later. K-means clustering as well, and they used a causal transformer. I'm not familiar with all of these technologies. Like, what is a causal? Is anybody familiar with causal transformers? No? Okay, that's fine. We can dip into that later. And they use a standard text to speech system as a decoder. So trying to use as much off the shelf stuff as they can, pre-existing models.
So does this mean they are using like from first doing speech to text and then text to speech? That's
No, they're not going to text. They're going to this intermediary representation, which they're calling the quantized unit.
Mm-hmm.
And
Yeah,
so
that was the dotted line path, right? What
that
was
is
there?
well, the dotted line part is saying going straight from the encoding to the decoding, which is simply resynthesis. Here, let's see a demo of this. Which one has resynthesis? Okay, so here's an example of resynthesis. So here's the prompt.
Love is a babe.
And so this is the resynthesis.
Love is a babe. Then might I not say so? To give full growth to that which still doth grow.
Okay. So that's the resynthesis. I'm not going to go through the other examples because we haven't seen those parts are yet. Does that answer your question?
Actually, I'm still a little not clear because there is this language model in between, right?
The language model is not text. The language model is these discrete units. So they're creating a new model, a new language model, which is fragments of the audio.
Okay, and in this language model, so using these units of audio signals, right? So that's what is coming as input to these language models. So what is so in a traditional language model, we say what is the probability of next word given the previous word, right? That's the basic language model.
Correct.
So now here it will be the probability of next audio, say, unit, given the previous audio unit.
Yes, exactly. So that's the vocabulary. It's not the token. It's not even a phoneme. So one thing they discover is not even a phoneme. So it's right here. So the entire stack is trained with self-supervision from raw audio, no text or labels. So it's entirely self-supervision. And the language model text-to-speech components were trained on pseudotext. So pseudotext is their vocabulary for these units. And that is derived from the raw audio. And so when they're comparing these models, they couldn't exactly analyze the pseudotext because they don't map to either letters or phonemes. And they did discover that the better models have more units than there are phonemes in whichever language. And they mentioned, okay.
I wanted to say quickly, we actually in some of the NLP lectures, we kind of, the homework, for example, touches upon models that have word types and word tokens and clear word boundaries, right? But the professor has mentioned byte-to-byte models, literally like, you don't know how with a real language model, you can't tell how large your vocabulary is going to be, right? You don't know how big of an embedding you're going to have. If you could build a byte-to-byte language model, you literally, like, by definition, have at most 256 embeddings that you might need, and it sounds very much like, well, I guess it sounded in nature similar to this because you don't have clear boundaries between what people are saying.
Yeah, I think that's exactly. I mean, that's still very well defined boundaries because it's the representation in the byte representation of that language. So it's still sort of a, you can call it an artificial boundary. And I think that was the byte 5 or something that we posted from last week. Was one of those models out of Google. And then there's also this concept, I think it's in 410, we discussed it, where we're looking at not just the frequency of a token, but also characters or previous characters. That was briefly mentioned in one of the 410.
Yeah, so it's like, if you look, typically the general pipeline, as what I have learned, is that you have a matrix representation let's say words, and you could have word by word metrics like we had right now. You do some kind of dimensionality reduction, and then you do the language modeling. So here looks like they are taking the word like that only, and then just using the audio signals to come up. What would be interesting to know is how they have built their test data set or trained data set. That's not very clear to me, at least in the description. As in, let's say if we have to build a model like this, how would the training data set look like?
Right. So right here, they talk about training with 6,000 hours of this data set of Libra Light and Libra Speech audiobooks. So these are professional speakers who are reading text, right? Reading pre-created text. So
yeah, but let's say in a machine learning or a basic thing, what is a training instance look like? Is it like the entire audio signal of, or is it like chunks of audio signal in the book? How does that? I mean, that's something would be very interesting, because at a high level, it's okay, 6,000 hours, but how was your training setup?
I'm not sure how we do it in just regular text, but I imagine they're following a similar format, whether they're using, a sentence at a time or a series of words at a time. Maybe it'll be explained better as we get lower but I know they're using these, strictly speaking, these audio books as the source, and trying to recreate audio book format, in that kind of vocabulary and way of speaking. So it is very limited, right? It's not just like us talking.
No, it's an interesting idea. Definitely, it's a very interesting idea. It's like representing voice without getting any intermediate representation. So that's really cool. What is really good is, I mean, how do you set up all this if you have to try it out yourself?
We're getting to it. All right. So the first step to get to that is, let's figure out how we're gonna score it, right? So they're using two scores, two evaluation metrics. They're using something called PER, phoneme error rate, and AUC, area under the curve, right? So if you guys can see this this picture, I mean, it's not that complicated here on the bottom, but so a comparison of the phonemes of the original input with the phonemes retranscribed by the ASR. The ASR is, what is the ASR? Pre-trained ASR. Does anybody know what the ASR stands for?
Audio speech recognizer, I think. Yeah, it should be automatic speech recognition.
Automatic speech where did you see that?
That's automatic speech recognition.
Automatic speech recognition, okay. So let's go back to this part. Okay, automatic speech recognition. So basically, they have a way now of determining the quality of the error rate of the particular model using phonemes, and then also the quality of the linguistic quality using the area under curve metric. And then they create something new, they call it temperature. And that's their designation of how they're scoring how good it is. The inventivity of the language. So lower temperatures are very rigid and higher temperatures are more variable. Okay, so this is really, we're going to spend a little bit of time on this to understand it. So let me just start with this chart, maybe. not zoom in as well as I like. Are you guys able to see that?
Yes. You can.
If you need to, open it up on your own laptop as well, just to have a better picture of it. So first thing here is a higher number yields better outcomes at acoustic level, though at the cost of higher bit rates. Okay, so this is looking at here on the bottom x-axis. This is the bit rate. And you can see here that this metric PER decreases as the number of units as the bit rate increases, right? So that's kind of intuitive, right? You're like, okay, if I'm on the phone, it may be harder to understand somebody than if they're right in front of me, right? Depending on the quality of the audio that you are hearing. Okay, this is the acoustic model on the bottom row, the language model on the top. And then on the right-hand side is a human speaking. On the left-hand side is automatic generation. And so they're even saying that, you know, humans are not perfect in terms of the error rates. And I believe MOS is a subjective evaluation of that audio. What's really interesting here is you've got these 4 different kinds of models being run, and Hubert always runs out better. And that's the Hubert is a variation that they did on the BERT model. W2V is the wave to VEC. I forget what CPC was. And logmel was a baseline that they used. So higher bit rates are better. There's a similar trend in the linguistic level. They did say that something happened where, like, if you use too many, then it wasn't as good. Hubert was the best. Automatic generation metrics correlate well with people. So basically the model, the automatic model, is actually working similar to how people would respond. They did create a metric for speed of the system, zero resource speech benchmark. It's actually the same group that created the metric. So that's what they did for that. And they said, this is just repeating the same thing, lower is better. So let's talk about this for a second. So what do you guys think about this chart of results? First, any questions about the chart? Because it's obviously got a lot of stuff going on.
Basic question. What is bit rate?
Bit rate would be, are you familiar with like music, like a CD versus a MP3 versus phone call?
No.
So like a phone call would be a lowest bit rate. I think it's like 32 bits, 32. Elliot, you know?
Yeah, I wanted to say it's the number of bits you use per unit of time to encode audio, right? So you can have the same audio, and then you actually need, like, you can have the same analog audio, and then when you transform it into a digital form, take your 1 second, and then the question is how many bits are you going to spend for that?
So is it the Shannon bits, or is it the actual bits of computational information?
That is a.
It just depends how you refer here. Let's just do a quick Google search on it. Bit rate definition.
Yeah, I think it's like the A to C conversion rate.
Audio to
No, like analog to digital conversions, like
analog. Okay, analog to digital conversion. So you can have a higher bit rate to create greater fidelity in the audio conversion. And so the idea is that if you use more information to represent, if you take up more bits, more information to represent the same audio, that is better quality, right? Lower error.
Okay, so essentially, the more information you can pack, the better the audio quality would be.
The better, yeah, the better the resulting quality of the audio in whichever format whichever evaluation metric you're using. And it's correlated to the human comparison.
Yeah, so I think the human comparison, what I understand is you speak the same thing. Let's say the model generates the audio and the human also generates the same audio, and that's how the comparison is done, right? That's what these two columns are referring.
That's a good question.
Because that's what, like, typically if you take any image or any other line, when they compare with human level performance, they always say we gave the same input to human and to the model, and the results, both of them produce the same result, and more or less we compare how they performed. So I'm assuming you give the same thing, you are doing the same thing here, that it's a audio to audio, right? So you give it to a human, how they generate it, and give it to the model.
I just can't say it with certainty, but that sounds right. If they're doing a comparison between human and automatic, that they must be asking the human to do it in a similar way.
Yeah. So on the x-axis, okay, let's go with that. So on the x-axis, we have the bit rate, and on the y-axis, we have these acoustic model.
The phonemes are right. How do you say the word? I don't even know. Phonemes.
Can you say it again, Ilya?
The air rate. I don't know how to say phonemes.
Phoneme, yeah. So the acoustic model is on the bottom row. The acoustic model is the audio model. And so you're going from speech to units and from units back to speech. And PER is their error rate, the phoneme error rate.
Mm-hmm.
Right? So you see an average decrease in the phoneme error rate as the bit rate increases across all models, right? So that's a common trend across all models.
I just wanted to know why are there 4 models being listed on the human side? I'm a little bit confused. So the input is, I think that maybe some audio, and human is generating the audio. Still,
The
there
4
are
models in the middle are the language model representations. So they're using this modified BERT as one of the model representations, and then wave to vec as a model representation. It's an embedding.
I think the question is why are there 4 models for humans in the human?
Yeah.
Oh, why is it 4 models for humans? That's a great question. My only suspicion is that they're still using the language models, but then they're having a person actually speak. Average negative Moss. There is an explanation of average negative Moss.
Do we want to maybe try to answer these questions later? I don't know, or do we want to focus on this?
Yeah, sure, definitely.
Okay, let's.
But I'm just thinking we could spend a lot of time trying to figure out whether if we're human graphs or we could actually look at the architecture.
Yeah, we'll get down there. Let's bring that question back up, like you said. Okay. Okay, just as an example, low, medium, and high temperature. All right, so low temperature, basically, they just keep saying the same thing over and over again. All right, so the property by James Resell read, the property, everything is like the property. Medium temperature still gets some coherent for a few words and some variation. It is attendant from the people to defend himself. This information pride of the potential in criminal activity, a curiosity, but it's still not quite like a sentence or something to be understood. High temperatures, you get a lot of variety, but not necessarily doesn't really mean anything. And some of the stuff isn't even real words. Asian of pure blue, he said, at once a licking streaming at her warm spot of half performed. I don't know, this probably should have been vetted. Was a raging oath, let it as bird of Amol. Just nonsensical to some degree. So they did find that if you use the Hubert model and you're able to get a medium temperature, then you start getting something that seems to be meaningful. So this is the prompt.
This reality begins to explain the dark power.
And then this is the continuation.
This reality begins to explain the dark power of the magical blackness, and in the midst of it is magical as a single blackness of the paper.
So that was audio to audio, right? Speech to speech with the model. Okay, now we get into something called prosody. I don't know how to pronounce this, so I'm just saying prosody. But prosody is, I pulled up the definition. Prosody is the patterns of stress and intonation in a language. The phonetics, the units that they were quantizing were differentiating like phonemes, pa, ba, but they had additional things that they were differentiating, and they were ignoring prosody. So they had to do a separate model for that. So they created this architecture. So on the top here is the standard speech to unit model. They added another one specifically for pitch. And they added another one specifically for the style of speaking. This is what we're talking about, let's say accents. So these are the three different models that they put together to then recreate the output speech. We won't get into the details of all this because it's quite involved. So just saying the same thing here. There's pitch units in the middle and the speaker embeddings in the bottom. And again, Hubert worked out to be the best. Best performing in terms of lowest error. One thing I was trying to figure out was this F0 score. Someone had a question?
Yeah, so Hubert is this performance is with respect to the architecture, the previous one that we just saw, or because that's like a ensemble architecture.
An ensemble architecture specifically for these three aspects.
Yeah.
And then they use multiple models within the same architecture.
Yeah, but okay, so like pitch, for speech to unit model, 3 options. CPC, it's not like a concatenation layer, right?
No. These are separate models that they're running. Yeah. So they ran one with CPC, one with Hubert, and one with VQ.
Okay.
Yeah. Okay, so let's listen to some of this.
The morale of the Yugoslav army is beginning to crack.
Are you guys able to see my this live caption screen? Is there like a little black box? All right.
Yep.
It was important to win the singles.
Now this new one is using those two.
The morale of the Yugoslav army is beginning to crack.
Should I play that again? I'll do the next one.
The referee is there to decide these things.
There is no reason at all. The referee is there to decide these things.
It's not bad.
What do you know? Can you say once again what does the reference voice do? What's that for? Is that on the speaker ID tuple? Is that what it's?
Correct. Right. So you're converting. So let's do it. Let's do the next one. Here's the original.
However, it is understood that offers of further pavements are unlikely.
However, it is understood that offers of further pavements are unlikely. And then
It does not stop here.
so that's the person's voice. Right? We want that voice.
Ah.
It is understood that offers of further pavements are unlikely.
Oh wow, that's pretty good. Okay.
Right. We took that person's voice and basically mapped it to the original message. Right. So this is not
It's deep faking, isn't it? Oh, sorry.
Go ahead.
Yeah, I mean, I'm sure that Facebook AI does not want to use that term, but it's deep faking people's voices, right?
It's deep faking, right? They don't want to talk about it. And there are other models that have already accomplished this. This is not novel. But what they do get down to a little bit later, and right here is, look, so they say, look, this is a 20% compression factor when compared to the standard codec, which is called Opus. And it's a 2 times compression factor when compared to, state-of-the-art vector quantized variation autoencoders, this deep fake audio methodology. But it can only really be used for audio, for spoken word. It cannot be used for music for this compression. So but it is interesting. Like you're getting better and better compression, which means that we could potentially have things like, a device that like these things that are real-time translations hang around your neck or pop in your ear, and you can talk to somebody in a target language, and it's just constantly translating for you, in real time, potentially without any internet access or a larger computing device.
Just a fun thing. Have you guys seen the movie Up?
Yeah.
There, the dog has a collar which when the dog speaks, it can speak in human language. So
Yeah, I mean that's an interesting translation, right? Can you accomplish that with other verbal utterances? Yeah, I mean maybe they can do that with brain mapping too. Okay, so this chart real fast. I know we're almost out of time here. Just showing that bit rate, we want lower bit rate, that's better. And this other metric on the vertical axis is telling you how performant, right? So uncompressed is the best in terms of performance. It obviously uses a tremendous amount of space in the representation, and they're able to achieve almost as good. It's almost better than 90% with far less data consumed. And there's some GitHub stuff here. All right, so this is getting into that architecture we're talking about at the very beginning. How are they doing this? I think we're going to get into this, right? We're looking at multiple n-grams here, but in this case, they're called, there's like a unit gram, and they're looking at the prior unit for the delay. Let me send a new image right here. So they're looking at the prior unit, one prior unit for the duration embedding and one prior unit for the pitch embedding, and the current unit for predicting the next spoken unit. Okay, so pretty simple. Oh wait, hang on one second. Sorry, my kid is going to try to get in this room. So adding these extra channels and tasks improves the language model performance. Sorry, in terms of perplexity scores of the units. Okay, so basically you get better performance by separating out the. Just give me 1 second.
Yeah, and meanwhile, I think I can answer Dinesh's question, which is that graph that we looked earlier, where we had the error rates. The y-axis was the error rate, and the x-axis was the bit rate. Those are not humans versus machines generating speech. It was the automatic benchmarking versus human benchmarking of the models. And the idea was to demonstrate that the trends were the same and that the automatic benchmarking actually worked. And the relative results are the same as when the humans label. When the humans try to determine how well the models perform. Yeah.
Okay, I'll get that explanation from you later. But okay, so here we're looking at, they are not changing the units. They're simply changing how the aspects of the duration and pitch are used, and then are able to get a different result for how it's spoken. So if we look at an example.
When an aristocracy carries on the public affairs, its national pride naturally assumes this reserved, indifferent, and haughty form, which is imitated by all the other classes of the nation.
When an aristocracy carries on the public affairs, its verification there may be in science, the connections of the valley to which it was called upon to lecture, conferring on similar descriptions of opinion, and in other instances which appear to have never exceeded the same results. It cannot be found that the notion of the most ideal opinion is the popular notion of the edifice, nor is the susceptible possibility of introducing the same state of the continental character. The scope of the theory of the notion of the...
Wait, I don't like that example. Let's use the other example. That one's really hard to understand.
She was quite shocked when I asked her whether wine was allowed at the second table, and she has turned away 2 housemaids for wearing white gowns. She was quite shocked when I asked her whether wine was allowed to sing sauntering, menacing stars, and finally asked to something like sending them to rhyme. It was a rough and thin range of mountains and a horse tower riding along the road. When I asked her whether wine was allowed to comply with her, and thinking that she was sometimes no better than wine marshallowed concerning the work of a cordial procession, as she could...
Okay, the only point of that was if you just change the delay and the pitch, parts of the architecture, you get completely different ways of the output speech. Okay, so lots of GitHub stuff to play around with and listen to get a better handle on what they're doing and what's going on. There's like hundreds of samples that they've produced for review. So where are they planning on going from here? They're going to look at the spontaneous speeches, right? Not the audiobooks, but like actual people coming up with things to say. And you know, they're claiming some things here where can this be useful? You know, if it's trained with few available label data like spoken summarization, spoken sentiment analysis, and information retrieval tasks. I'm kind of curious, you know, where this is really going to be applied. I think the concept that in general this is audio only or audio first maybe has a lot of benefit in for children specifically.
I think one usage, at least in Facebook's products, this could be very useful for Oculus, wherein you are playing a game, you're in that virtual environment, and then because I have played a couple of times on Oculus, it's like when you're communicating with your team members or fighting with others, and it's very helpful to understand what everybody is saying at the same level. Sometimes the voice quality is also not good. So probably one usage they could probably, the inspiration might have come from Oculus.
So basically you're saying that inside of a game, you're speaking to another player or you're speaking to.
Yeah, you're speaking to the to another player, like if you're in a team game.
Okay. Any other ideas or thoughts on it that people have come up with, like areas they could see it useful or areas of personal research or interest?
I'm kind of surprised that Facebook is using this model because traditionally Facebook doesn't own a lot of like audio data, as opposed to like YouTube, for example. Like YouTube has like billions of videos, right? But Facebook only has text, I think, except for like the WhatsApp, like short messaging, something like that. Yeah, so I'm kind of like really surprised that like Facebook would be coming up with this approach to train audio on audios without text, because like they have a lot of text but without the audio. But hopefully,
trying to focus a little bit more on their Facebook Live approach, their availability, if I had to guess. It seems like they were copying a lot of Instagram's features, and it seems like Instagram was getting really into video, especially with more complex files being easier to transfer over Wi-Fi. I mean, internet speed's getting faster constantly, video is easier to transfer. So I wouldn't be surprised if Facebook is trying to become more video friendly. But that is a good point. It's mostly text at this point.
Yeah, their main feature is the feed, right? And so if the feed is not going to be text anymore, they got to know how to accommodate for that.
I also just think it's interesting that they're working with audiobooks, because in my mind, like I've listened to audiobooks, the voice that you use for that is so specific. You can hear it at a glance, like, oh, this is someone speaking from an audiobook. It's a very specific timbre. So I'm interested to see what kind of shortcomings come from using that as a data set, because I see the benefits of using that because it's so much data available. But again, I've never heard much of a deviation from that standard audiobook voice.
Or the newscaster voice, right? Like that's it.
And you can even hear like NPR voice. It's yeah, it's very standardized.
Yeah, I think like audio is a good source of training because like it has already labeled it audio signal, so it's easier to verify it like from human point of view, I think. Probably is a good starting point for audiobooks, but later on they will maybe move on to other like video, like for example like the new feature about feed they are going to improve, like incorporate into their products.
What about helping people who can't see, like blind people? Like if let's say you want Facebook for blind, then you need something like this, right? Wherein if there is a post, it can read out to you in the proper essence or convert that something. I'm just thinking maybe that's another way to expand your consumer space.
I think that's right in line with that same concept. Is can I hear that message that someone has posted in that person's voice?
Yeah.
Right, like because it's awkward to just hear the same things being said.
Same thing, exactly. There's no personalization. There's no that personal touch is not there.
Right. Can you guys think of any other embeddings besides audio, or we talked about byte, like byte to byte sort of embeddings? Can you think of anything else? Because it just seemed like I always just assume like if you're going to do something, you have to do it in like text or whatever. Like you have to understand it. But they're saying no, like you can just.
So if you look, there was one post I think on linguistic, some video lectures, and it said that the base of any language, these words, even the base for those words are phonemes. So essentially somebody created those phonemes, and from those phonemes words came, and then from words the meanings and all this came. That was the whole path. But now with this, just let's say if you attack phonemes, you are attacking at the root level, and you don't need that entire path. You can just jump from phoneme to another. Maybe you discover other phonemes which were not even thought of before, because they are the root. They are the most fundamental unit of language or speech. Have you guys seen that lecture on linguistic, or there was some post?
Yeah, I think I agree with you, Samart. So basically, I think I have read it somewhere that somehow the words are actually generated from the voice we spoke and the way we speak. I mean, like some like if you notice that some emergency words and some all those words are having high frequency. So that's because we used to be, a bit shrill when we had some emergency and we wanted people to have our attention. And for bass, we usually used to have a very simple situation, and that's why some words which has some bass in it are not that emergency related situation words. So I think that it's true, but still I would like to, point out that it's about communication to humans right now. I don't know. So if we are not at that level and learning at phonemes, isn't it going to take much more time, and it might be more error prone as compared to text, because they might develop their own language that's good. I mean, it's okay, but eventually you want to communicate to humans who are not going at that level right now, uh, understanding text better as compared to phonemes.
I think it's about that's for humans, it will be a translation thing. But let's say how we humans interpret a word. Let's say if I read a sentence, then I am painting a picture. If it's a vocal thing, right? Somebody's the sentence says the girl uh, was excited and started shouting, or the boy was excited and started shouting looking at his or her friend. So now when we read this sentence, there's a picture being built in our head, right? That somebody came, they started shouting. Now shouting is a very you can say a high pitched thing that is happening. So probably that kind of interpretation coming out. So let's say if you read that text and you put it in a way that somebody shouted, that is real thing, right? I mean, versus in traditional audiobook, it's like the person came and started shouting. So that's I think, in my view, that's where the real quality is going to come, as in how you think of shouting in your head, and in reality how shouting is in terms of voice comes out.
So you mean to say more personal? I mean, not. I mean, adding more texture.
Yeah, adding more texture, more in terms of audio books. I'm just thinking always of audiobooks. Is when you're reading, it's a very bland pace at which things are going. There's not very much variation. So that
There,
that
I mean,
could be.
there are audiobooks where you have multiple different speakers, right? And they do the audiobook in a different way, and so therefore, like, you may prefer that style or that person's reading. I mean, that's where this prosody thing is so interesting. We may be able to take historical people, right? We have their samples, and we can have them read a book or give us a newscast. You could have your newscast and your favorite anchor, giving it to you.
Yeah, it could be, let's say a big application could be just select the personality or the person who you would like to read this text, and just then the thing changes. It gets communicated in that voice.
Yeah, the weirdness comes in and be like, I want my maybe past father or grandfather to read stories to my kids at bedtime, right? And that's some aspect of this as well.
Well, actually, that's also very good insight in my view, because people generally miss. Let's say if you want to hear your voice of your parents or anyone or your dear one, then reading it out to you, it's difficult. But with this feature, it's pretty powerful, I would say.
Vitral, just wanted to ask one thing. If you had noticed that, like you had mentioned that there was no understanding going on, like at morpheme level they are, but I don't know how morphemes connect to one another and how grammars play roles there. I don't know about those things. So I am assuming that this is totally non-understanding based from human perspective, at least.
Yeah, so there is so from an there is another description about what is understanding. The way human understands is not necessarily what a computer understands, but at the end of the day, the communication should be that the computer understanding gets translated into human understanding or human consumption. That's the thing. It's also, if you look at word2vec and other things, they are also the same thing. The embeddings that get generated, no idea how things are being done, but at the end of the day, it makes sense.
This is why I was trying to get to that idea of like other kinds of embeddings. So maybe there's another embedding that's more of a knowledge representation that is irrespective of the inputs and outputs. Maybe it's a visual representation, or it's just purely conceptual representation that we start with as children. Like, okay, this is inside, this is outside, this is up, this is down. You know, this is this kind of texture, and then that gets mapped in, right? However that is formed, but it could have multiple ways of triggering. You know, it can be this audio, it can be whatever we can simulate with visual, whatever we can simulate with like touch, like however that maps out. So again, all right. So because the big area of research now is artificial general intelligence rather than this, you know, machine learning types of intelligence, which is just more task oriented. I'm not really saying anything more than just my brain is generating stuff, right? Based on the inputs that you guys are giving.
I think this was really good. I mean, it started giving ideas. So at the end of the day, that's what counts, at least for me. It's good ideas. They're good ideas.
Yeah, it's fun. Does anybody have any final conclusions or thoughts? I know we're basically at an hour. Ilya's probably in the background doing some research for us. I don't know.
No, I'm not only here to ask people if they have. Yeah, I don't know. If we run out of topics, we can conclude. And if not, then say so before I end the meeting. Okay, 1, 2, 3. Okay, thanks everyone for coming today. We will see each other next week. Bye.
Bye.
Hey, thank you so much.